We've been doing a lot of talking about the Kounotori 3. It is scheduled to launch tonight from the Tanegashima Space Center in Japan. Aboard that cargo spacecraft, we have about 3.5 tons of cargo that is scheduled to go up. 20% of that cargo is experiment-related equipment. And so here to talk with us today, we have Pete Hasbrook. He's the Associate Program Scientist. Welcome, Pete, and thank you for coming.
Thank you very much. I'm glad to be here today.
Well, so as we were saying, there's about 3.5 tons of cargo that is scheduled to go up. 20% of that cargo is experiment-related equipment, and a lot of our equipment that's actually going up. And so Pete is here to talk to us a little about that. But first, I'd like to talk a little about you.
Okay.
So tell me first how you came about coming to NASA, how you made your way to where you are now.
I've been at JSC for 27 years. I grew up in Michigan, studied aerospace engineering at the University of Notre Dame, and came here to the Mission Operations Directorate right out of school. I held 2 different positions on the shuttle flight control team in operations, and then about 10 years ago I came over to the Space Station Program Office, which is the program management of the International Space Station. About a month ago, I started my new job, which is the Associate Program Scientist.
Wow, so you're new to this thing. So I understand, so you were an increment manager, and so you obviously know a lot about the ISS, or Space Station operations, and so we'll get into some of that as well, as obviously there were some station operations and also some partnership things that took place for getting our payload on board. The cargo ship that is scheduled to go up. And this is the second operational Japanese cargo ship that's going up, correct?
Yes, it's the third of the HTV vehicles. The first one was a demonstration mission, was fully successful, and so now the second and third are the ones that we've relied on for all the good cargo.
Okay, so a month into your position as the Associate Program Scientist, explain a little bit about that.
So a program scientist, as a part of the International Space Station Program Management Office, the program scientist represents the science aspect of the station. The station is a laboratory. It's a huge laboratory. It's a huge complex to manage, so there's a lot of competing interests in managing that, keeping the crew safe, keeping the crew supplied, keeping all the systems up and running, keeping the crew healthy. But we want to use the laboratory for its purpose, which is science, investigations. We also want to do that as the international partnership, which is set up. And that's kind of where I come in. My previous job as an increment manager was a mission manager, and I worked extensively with the international partners. Now, in the Program Science Office, I will be focusing on, again, working with the partners, but now more on collaboration, making sure we're using the station effectively, communicating with those partners, looking for synergy and collaboration. And then the other part of what a Program Science Office does is we report on what we're using the station for. Some of that is reporting to management, reporting to our partners, reporting to headquarters in Congress, how effectively we're using the station, and then also educating the public, whether it's educating our NASA employees to go out and talk to the public, or just in general something like this, telling people what we do. We have people today in New York for the opening of the Enterprise at the Intrepid Museum. Some of our office are out there telling people about what we do.
Very interesting. So now I want to talk about some of the things that are going up, because we do have a lot of really interesting things, and I'm really glad to hear that you referred to the space station as a laboratory, because I think sometimes we forget that it's not just an orbital home flying in space that is there that we're sending people up just to maintain. There is a reason that we are there, and that is for the science that we are able to bring up. And so obviously, like I said, there's about 20% of that 3.5 tons of cargo that is being launched to the space station. That launch, again, is going to be 9:06 p.m. tonight. We'll also have coverage of the launch at 8:15 p.m. here on NASA television as well, for those of you who are watching. So let's get into some of those things that are going up. One of the payloads, the NASA payload, that is going up aboard the HTV-3 is the SCAN testbed. Now, SCAN is an acronym, excuse me. Space, Communicators, and Navigation.
Yes.
So explain to me what that is.
Okay. The SCAN testbed is it uses one of the unique capabilities of the HTV, in that HTV can launch external cargo that never comes inside the station, but it gets mounted outside the station. In this case, the SCAN testbed is demonstrating advanced radio technology. The principal investigator is at Glenn Research Center. the other major investigators are at the Goddard Space Flight Center, as well as the Jet Propulsion Laboratory. It's in demonstrating new communication methods, for instance, the software-designed radios. Traditional radios have a lot of internal hardware components, transistors, tubes, the converters. This new technology uses computers more, uses modems, and it's a reconfigurable radio in a sense that you can launch it on a spacecraft, let's say, and then if something changes, like you can reduce the power level because you don't need as much power, you can do that through your commanding. You don't have to bring the radio back to the ground. It's also testing advanced navigation technologies. And the scan testbed is going to be removed by the robotic arms on the station, and it will be transferred up to an external location on the station so it can see satellites, communicates in several different wavelengths.
Okay. Okay, great. Well, so I think one of the benefits you mentioned was the fact that, so basically we can fly that piece of hardware there, but then we don't have to keep bringing it back and forth. And so essentially it's just a software swap out, correct?
It's using new hardware. It's demonstrating how that hardware can be commanded from the ground, change the software inside that hardware. Another advantage of using the station, you could launch this hardware on pretty much any satellite that's going around the Earth and test it. But the station is there. It's a national laboratory, so it's an opportunity for us to take equipment to our laboratory and demonstrate it.
Okay, very good. Interesting. So let's move on to another one I found very interesting. And there's a long list of things that are going up there, so we're really only just touching base on a few items. But one of those things is the aquatics habitat. Now, this I just find very interesting because we're talking about fish in space.
I do too, yes. The aquatic habitat is going to go into the Japanese experiment module. It is the aquarium system that will let the Japanese scientists study fish. There are no fish in this aquarium yet, but it's setting the systems up. It's a complicated system. If you think of an aquarium, it's got pumps and filters, and through the filters it puts oxygen back in the water for the fish. The neat thing to me was imagine an airlock to get outside the station. Well, some way you need to get the fish in microgravity. So there's basically a water lock where eventually the fish will come up in some kind of a container, and you have to transfer them into the aquarium without letting the water get loose. The fish that they're going to study are the Medaka fish. Here in the U.S., our researchers use mice because we understand mice, we understand them as a model of the human body. So we understand if a mouse reacts in a certain way to a drug or a disease, how that might apply to the human body. The Japanese have a history of studying fish, and the Medaka fish is a model for them of the human body. So in a sense, they've got so much history on the ground. If you fly the fish and study it in microgravity, you understand the history of how it reacts on the ground. So you can apply that to what you're seeing in microgravity.
That makes sense, and it's really, really kind of exciting to think about fish in space in an aquarium. Can you describe for me about the size of this aquarium, what the aquarius habitat?
The facility itself is probably about 1 meter wide. It's going to go in a half rack in the gem. The fish will be inside a much smaller container in that rack. It's about 7 centimeters by 7 centimeters by maybe 15. That's how big the aquarium is. The fish themselves are fairly small, so they fit in there. The aquarium not only has the life support systems for the fish, as I said, it's also got cameras that can monitor the fish as they're progressing, see how they're doing.
Okay, and then what type of fish are we talking about? Freshwater, saltwater?
I believe they're freshwater fish.
Okay.
Don't quote me too much on that.
I'm going to quote you. You're on TV.
Yeah, I know.
Okay, so another major science aspect that we work on continuously is Earth observations for a number of reasons. And so we've been doing that for, just in the crew Earth observations for many, many years. And so obviously, and there's obviously really great advantages of the vantage point of the space station, not only from where it flies, but the fact that it flies all around the world at many, many times in even one given day, and literally can cross every part of the Earth. So I understand we have a new camera, and this is called the iServe. This is an Earth observing camera that's going to be brought up, and this is a remote controlled. And so if you can explain to me how it is remote controlled.
Okay. The iServe camera is a new design. It's the result of a cooperation of NASA, and USAID, the Agency for International Development, I believe it is. The idea is that we want to use satellite and spacecraft technology to the data that comes from those, pictures of the Earth, rainfall, and get that out to governments. And in this case, one of the major users is the Surveyor Network in what they call Mesoamerica, so Central America and the Caribbean. Countries that don't have access a lot of times to space-based data, but are affected quite a bit, whether it's earthquakes or rain or flooding or hurricanes. And the idea here is let's use the station's capability and our imagery to get that out to these governments so they can see what's going on in their countries and their countryside and make decisions about how to respond to disasters or potential disasters. The station has a great window in the laboratory. It's an optical quality large window, and we're going to use it with this new camera. This camera is really a digital camera looking down the barrel of a bigger telescope, about an 8-inch telescope. This telescope is on gimbals, so the ground can command it to one side or the other of the ground track. The program will know when we're going over various parts of the Earth, and if there's something that the ground wants to see, they can set it up to take pictures of specifically the area and then share that.
Okay, and so it would only require, as far as crew time, just to activate it, or is it all automatic?
Basically, to initially set it up, set it within the window, set up the computers. It's controlled by a laptop computer, so it's a very small footprint. Once the crew sets it up, the ground will be able to monitor it. The ground will be able to predict it. The ground will be able to command it to change and take the pictures and downlink the pictures.
That's very efficient.
Mm-hmm.
So, and again, those photographs that are taken of the Earth are not only beautiful to look at, but they actually do serve a purpose for, some research that we are doing here to help understand. And obviously, in those development countries where they don't have the capability of being able to, study those, and especially that they are hit with things like hurricanes and tsunamis and, wildfires and that sort of thing. Not only from a disaster standpoint, but also from an environmental changes part, correct?
Yes, yes. So these cameras can take a history of the ground areas that they're looking at, whether it's a seasonal history or years in the making history, see how things are changing. You can use that to say this area needs more fertilizer, this area is at risk of mudslides. So it's a good way to use the technology. Another benefit of the station is it's at relatively low altitude. So the pictures are closer to the ground. We can get better resolution.
Better. Very good. That's interesting. So now another one, and this is kind of a fun one, I think, is the YouTube Space Lab.
Yes.
Tell me a little about what that is.
As we know, I'm new to this office and I've just been learning about it, but in the last couple of days, as I've looked into the YouTube Space Lab competition, I'm really impressed with what they've done. This is what we call an educational outreach, public outreach activity. It was sponsored through YouTube and public sponsors, and the target is kids in, let's say, middle school, high school. There were two age ranges, 14 to 16 and 16 to 18. And it was to get into this competition, the idea was pick something in physics or in biology and propose an experiment to be done on the International Space Station. And to do that, you had to submit a 2-minute video of yourself, introducing yourself, what your concept was, what your hypothesis was, how you would test it, and how would you use your results. They had something like 2,000 entries. They've had millions of views on this YouTube website. So they narrowed it down to about 60, I think, finalists, and part of the voting to select the final was through the public voting on the YouTube website. They narrowed it down. The two finalists are having their experiment launch on the HTV, and it will be operated by the crew. And the neat thing that I saw as well, Sunny Williams was the one who announced the winners. I think it was last December or January. She's on board now. She will be the one executing the experiments. There were two individuals that won. One was a set from Michigan, my home state. Two young ladies that proposed a biology experiment. They saw that results of previous research that said salmonella gets more virulent on station in microgravity, meaning that it's more effective, and in that case, it's more dangerous to you. Well, they thought, we know of an antifungal, let's fly that. And the premise is, if it works this well on the Earth, maybe in microgravity it does an even better job. And we care long term about fungus on ISS. You get mold on walls. It's a bad thing. It can deteriorate your walls, your metals on board. So they proposed this experiment. It's got what we call controls on the ground. They're going to monitor how the fungicide reacts on the ground, and then see how it reacts after having flown in space.
Wow, I'm always amazed when we have some of these educational type research projects that are going up, because there are a lot of smart kiddos out there, let's face it. And it's really neat that we're able to send that up there. And, you know, it's in the end, what we learn from that in turn helps us as well.
I think we may have the website here, but if you go search on YouTube,
we do. It's at that website again is at www.youtube.com/spacelab. So you can go and look at all the videos that they have there and the contest. And I know there are a couple of Q&A, scientific Q&A videos there as well. So have a visit and check that out. And now I want to talk about, so like I said, we have a huge list of things that are going up, and that's, I mean, really good, because again, like you said, space station is a lab, and that is what it is. So like I said, 3.5 tons of cargo is going up aboard the Kounotori3, again, the second operational cargo ship from Japan. So I want to talk a little about the space station operations and that the international partnership.
Okay.
How we get this stuff to Japan and on that spacecraft and up to the space station. How do we work with our international partner?
We first off, we need to decide what we're going to fly, and we have projections on how much food the crew eats, what they're going to need to wear, how much medical equipment they need. We also have an extensive process of looking into the future and what science will be ready to fly, what science we need to fly in that time frame, what the crew will be trained for. So there's a process to look at all that and divide up the cargo allocation among the crew supplies, among the emergency and maintenance supplies, and then especially we want to get as much utilization or research hardware on board as we can. So once we've defined that, we know what hardware needs to fly. There's a manifesting process, as we call it, that says this is how much it weighs, how big it is, this is when it can be delivered. There's a lot of folks that work with the scheduling and delivering the hardware, making sure it's safe, making sure it's packaged correctly. That then is delivered, in our case here at JSC, and then it's shipped over to Japan and turned over to the Japanese to load into the vehicle.
Okay. And how far in advance did they send our cargo to Japan, and for the loading? How long did that take? Do you know?
I don't know. I wouldn't even.
You're new. You've been here a lot.
It was also a part of my old job that I didn't do so much in.
Well, that's okay. We won't hold you to it.
Okay.
So again, we have another website you can go to learn more about these things that we talked about and the rest of that list. If you go to www.nasa.gov/mission_station pages/station research. Now, the easy way to go there is www.nasa.gov/station. On the left-hand navigation, just click on research and you can find the whole list there. You can search it by experiment name, alphabetically, you name it.
We have a couple areas, if I can interrupt. We have areas specifically for researchers. For if you have an experiment that you want to fly on the space station, there's a section for researchers. There's a section for teachers, for educators, how we can get NASA projects into your classroom. And then for students or for kids, there's another section that say, I have an idea for something I want to fly on space station. There's a section for them on there.
Great. Thank you so much. And also, if you want to follow along,
yes, please.
More of the research, go to Twitter, twitter.com/ISS_research. I'm sorry, not slash, it's just ISS_research on Twitter. You can learn everything that's going on. The newest updates will be there. And thank you so much, Pete, for coming. And again, we all look forward to the third space cargo spacecraft from Japan launching tonight at 9:06 p.m. Central Time. And we will have live coverage for you here on NASA television at 8:15 p.m. Central Time, 9:15 p.m. Eastern Time, and then that cargo spacecraft will then dock to the space station with all this good stuff aboard on the following Friday on July 27th. This is Mission Control Houston.